Assalamualaikum and hello. Today we at group 6, which consists of me, Amzar bin Azam, Muhammad Zakwan Zakirin bin Abdul Razak, Muhammad Danish bin Tazurin, and Shazly Iman bin Shamsul Fansury would like to talk about the cross-validation techniques, leave one out. So this is the content of what we are going to discuss. The first is what is leave one out. Second is advantages and disadvantages. Then the workflow that describes the step-by-step process of LOO. Then the mathematical representation. Then the visualization and benefits and use cases. And lastly, the best practices of leave one out. So what is leave one out? The definition of it is cross-validation is a technique where each data point is used as a validation set while the rest of the data is used for training. The purpose of leave one out cross-validation is to estimate a machine learning model's performance on unseen data. It helps in model selection, hyperparameter tuning, and assessing generalization capabilities. By iteratively training the model on all but one data point and evaluating it on the held out point, leave one out provides an unbiased estimate of performance and aids in identifying outliers or influential data points. So the advantages of leave one out is it is unbiased performance estimation, which provides an unbiased estimate of a model's performance since each data point serves as a validation set exactly once. This reduces the bias that can arise from using a fixed validation set. Another advantage is that it has maximum training data. Leave one out allows you to use the maximum amount of that training data for model fitting. Since each data point is used for training, the model learns from as much information as possible, potentially leading to better generalization. And lastly is the sensitivity detection. Leave one out helps identify the sensitivity of a model to specific data points. By evaluating the model's performance on each data point individually, you can identify instances where the model performs poorly, potentially indicating outliers or influential observation. Then we move to the disadvantages of leave one out, which is high computational costs, because it is computationally expensive, especially for large dataset. The process of iteratively training and evaluating the model for each data point increases the computational burden. Consequently, leave one out may not be feasible for extremely large dataset or models that require significant computational resources. The other disadvantages are potential overfitting. In some cases, leave one out may lead to overfitting. Since each training set is nearly identical to the original dataset, the model might become too specialized into the training samples. This can result in optimistic performance estimate during evaluation, especially if the model is complex or prone to overfitting. Lack of variability. With leave one out, there is little variability in the validation sets since each validation set consists of only one data point. This limited variability may lead to overly optimistic or pessimistic performance estimates, depending on the dataset's characteristic. That is all for me, and I will pass to the next person.
Assalamualaikum and a very good day to everyone. My name is Muhammad Zakirin, and now I'm going to present about the workflow about the leave one out cross validation. Before we start the flow, we need to do the pre-process and get the accuracy performance metric, which is the accuracy recall F1 score, and after that we can start do the leave one out cross validation. First, we split the data over the iteration over the data point. The data is categorized into two data, which is the first is the train data, where is the all data point except the current evaluate data, and the second data is the test data, which is the current data point. Next, we move to the train we train the model, which is we feed the model to the training data and optimize the model parameters. We can use the technique of the gradient descent or the cross validation. Next, we test the model. We use the test set, which is the current data point, to evaluate the performance. Then we make the prediction using the trade data and compare with the true value in the test set. After that, we compute the performance matrix, which is we calculate the predicted value and the true value from the test set. Then we store the result into the current iteration. And this process we need to be repeated and so on. And after we get the result for each iteration, we aggregate the performance matrix uh, that obtained for each iteration and get the overall assessment of the model performance. Next, move to the mathematical representation. This formula is get from the Rod-Hindman notation, which is the cross validation equal to 1 over iteration, and this yi is the full fitted model using all observation, and the back of the yi is the predicted value of the full fitted model, and we over 1 minus the hi, which is the leverage statistic for observation I, and we over the 2. That's all from me. Thank you.
Okay, Assalamualaikum. My name is Shazly bin Fansury, and today I will continue my presentation on explaining the cross-validation techniques on leave one out. So on the visualization, I will head to this page. So as you can see, this is a visualization on leave one out illustration. So on the right side, you can see the pictures as a surface of understanding on leave one out cross validation. So why is it important? Because the first one is why do we need for visualization in leave one out? It's because it assess model robustness, which is visualization assesses how well the model performs when different data points are excluded. And moving on to on the other hand is identify the influential data points which help the visualization identify that the data point that significantly impact the model's performance, such as you can see in terms of other types of uh, cross validation. So this one is it does impact on the model's performance, which is it shows how accuracy and precision on the model's performance. So moving on to the next one is detect the outliers, which is visualization identifies potential outliers that affect the model's performance during leave one out. And for a better understanding is to understand the model generalization. Visualization shows variations in performance across different left one out data points that which is indicating model generalization ability. So pass to the next for leave one out cross validation best practice. Thank you.
Okay, so I will continue with LOOCV best practice. So, use LOOCV with caution for large dataset. LOOCV involve training and evaluating the model for each data point, which can be computationally expensive for a large dataset. Consider the trade-off between computational resource and the benefit of using LOOCV for large dataset. Alternative cross-validation techniques such as k-fold cross-validation may be more practical. So the second is combine LOOCV with others validation technique. So LOOCV can be combined with other validation technique to further assess the model's performance. For example, you can perform LOOCV for model selection and then use a separate validation set or holdout set for final model evaluation. So the last is validate. Validate result on an independent test set. So after using LOOCV model for model development and selection, it is important to validate the final model on an independent test set. This helps to assess the model's generalization performance on unseen data and provide a more reliable estimate of its overall real-world performance. That's all from us. Thank you.